The crisp Florida air of January 28, 1986, held a particular chill, one that would etch itself into the collective memory of a nation. It was a Tuesday, and millions, including countless schoolchildren watching live from their classrooms, tuned in to witness history. Space Shuttle Challenger, mission STS-51L, was poised for launch, carrying a crew of 7. Among them was Christa McAuliffe, a social studies teacher from New Hampshire, chosen from over 11,000 applicants to be the first civilian in space. A symbol of NASA's commitment to bring space exploration closer to the everyday American. The crew was a vibrant tapestry of American ambition and expertise. Commander Francis R. Dick Scobie, a seasoned Air Force veteran, led the mission. The familiar roar of the engines filled the air, and a plume of white smoke billowed as the shuttle ascended. For the first few seconds, all seemed normal. But hidden from the joyful spectators, a fatal flaw was already unfolding. These were the O-rings failing. The frigid temperatures had indeed compromised their elasticity, preventing them from forming a proper seal. Hot, pressurized gases, burning at thousands of degrees, began to escape through the joint. For a brief moment, molten aluminum oxides from the burning propellant partially sealed the breach, creating a fragile, temporary barrier. Pilot Michael J. Smith, a Navy commander on his first space flight, sat beside him. Mission specialists Judith Resnick, an electrical engineer and the second American woman in space, Ronald E. McNair, a physicist and karate black belt, and Ellison Onosuka, an aerospace engineer, rounded out the NASA contingent. Gregory B. Jarvis, a Hughes aircraft engineer, was a payload specialist, and then there was Christa, her infectious enthusiasm radiating from every press conference. Challenger, go at throttle up, Capcom Richard O. Covey calmly announced at T+68 seconds, instructing the main engines to increase thrust. Commander Scobie's Roger, go at throttle up, was the last communication ever received from the Challenger. At T+58.788 seconds, a bright, distinct plume of flame erupted from the right SRB. A catastrophic jet of fire aimed directly at the external fuel tank, a massive reservoir of liquid hydrogen and oxygen. While the initial blast was not immediately fatal, the subsequent violent forces and the rapid loss of cabin pressure rendered the astronauts unconscious within seconds. There was no escape. Not a conventional explosion, but a rapid, violent disaggregation of the vehicle under extreme aerodynamic forces and the sudden release of the highly volatile propellants. It highlighted not only the technical failure of the O-rings, but, more profoundly, a deeply flawed organizational culture at NASA that prioritized schedule pressures over safety concerns, ignored engineers' warnings, and suffered from a normalization of deviance, accepting previously unacceptable risks as routine. President Reagan addressed the grieving nation, speaking of the crew as pioneers and directly addressing the schoolchildren who had witnessed the tragedy. The image seared into the minds of those watching, as a Y-shaped plume of white vapor and debris against the clear blue sky. The night before, temperatures had plummeted to near freezing, the coldest ever for a shuttle launch. Engineers at Morton Thiokol, the contractor for the solid rocket boosters, had expressed grave concerns about the integrity of the O-ring seals and the SRB joints at such low temperatures. Improvements included redesigned SRB joints, a rudimentary escape system for future missions, and a renewed emphasis on independent safety oversight. The tragedy served as a brutal, unforgettable lesson about the inherent risks of human spaceflight and the critical importance of listening to dissenting voices in the pursuit of ambitious goals. The memory of the 7 brave souls aboard Challenger, Scobie, Smith, Resnick, McNair, Onosuka, Jarvis, and McAuliffe, endures as a poignant reminder of the price of progress and the enduring human spirit that continues to reach for the stars. The tank's internal structures collapsed, and the SRB's lower strut, connecting it to the external tank, broke. The right SRB, now untethered and compromised, pivoted violently, its nose tearing into the top of the external fuel tank. These rubber O-rings were designed to prevent hot gases from escaping the booster. Previous flights had shown blow-by of hot gases past the O-rings in colder conditions, indicating their vulnerability. Morton Thiokol engineers even famously used a cup of ice water to demonstrate how the material lost its resiliency in the cold. Despite these urgent warnings, And under immense pressure to maintain the ambitious launch schedule, NASA management, particularly at the Marshall Space Flight Center, ultimately overruled the engineers' recommendations. The launch was approved. At 11:38 a.m. EST, the Challenger lifted off from Launch Complex 39B at Kennedy Space Center. Just 0.678 seconds after liftoff, cameras captured faint puffs of dark gray smoke escaping from the aft field joint of the right-hand SRB as Challenger soared skyward. Battling wind shear and aerodynamic forces, this temporary seal buckled. On the ground, flight controllers, initially unaware of the growing inferno, continued their routine calls. Within seconds, the searing flame from the SRB began to burn through the external tank. At T plus 73 seconds, at an altitude of 46,000 feet, the external tank ruptured in a cataclysmic explosion. The crew cabin, surprisingly, remained largely intact for a time, continuing its upward trajectory with other pieces of debris before arcing and plummeting into the Atlantic Ocean. The nation reeled. The dream of space exploration, once seemingly routine, had been shattered in a horrifying instant. The investigation that followed, led by the Rogers Commission, was scathing. The Challenger disaster forever changed NASA. The shuttle program was grounded for nearly 3 years, undergoing a comprehensive overhaul of its safety protocols, design, and management.